So the first question we're going to take a look at is describing the transformations. And the first thing you generally want to do is figure out how many there are. So how many transformations are there in this problem if it's coming from this as the original?
So repeat that again?
So how many transformations are there in this one?
On this one? 3?
No, more than that.
So, A, B, C, D. 4?
Yeah, there's going to be 4. Yep. What's going to be the first transformation that we do?
So it's A, so that would be the 2.
2, yep. And what is that going to do to the graph?
That is a horizontal shift.
Yep.
And it's going to be to the, let me look at my notes real quick. I'm pretty sure is positive left?
Yeah.
Okay.
So it's going to be shift left 2, so that's good.
Okay.
Now, is there a number in the spot that we had B?
Is there a number in the spot where D is?
B.
B. Technically 1?
Yeah, it's really technically just a 1, so we don't have to worry about that.
Okay.
So there's nothing to deal with for B. How about C?
C, that is the -3, right?
Careful, that's 2 things you named.
Repeat what you just said to me?
So you named 2 things.
Okay.
We just want to know, is there a number in the C spot?
In the C spot.
Yeah. Not if there's
Yes.
something in front of C, but just C itself.
Yes. There's
Yes.
something in C, yeah.
And what number is in the spot for C?
3.
Just the 3. Yep. And what's the 3 going to do?
The 3?
Yep.
3 is going to, see, is a vertical stretch by a factor of 3.
By factor of 3. Perfect. Now we want to deal with the negative in front of the 3. What does the negative do?
Then the negative, let me see, it says here, we're going to do a vertical reflection.
Yep. So it's a vertical reflection, or you could also say reflect over the
X-axis.
x-axis. And what's the last thing?
The -5, which is the D.
Yep.
And that is going to be a vertical shift to the right.
Can you say that again?
That is a vertical shift to the right 5.
Not quite. So it's vertical, right?
Yeah, vertical. No,
Vertical.
sorry, up. No, wait. Oh, did I put that down wrong? Okay, I think that is vertical shift down.
Down.
5.
Yes.
I put, right, it says here left and right, let me fix that.
Yeah. So vertical shift down 5. That's perfect.
Okay, thank you.
All right. So our next one we're going to look at is solving a radical equation. And the first thing we have to do is look at it and say, is the radical by itself on one side?
No, I didn't.
No. What's preventing it from being by itself?
-5.
Right. We got that -5 on the left. So we're going to move the -5 over to the right.
By adding 5 to both sides.
Yep. So we're going to add 5 to both sides.
Cancel out the 5.
Yep. Cancels out the 5.
To a 17.
So 17 on the right. And what would we have on the left?
It would be the square root of 2x plus 3.
Okay. Is the square root by itself now?
It is by itself, yes.
Yep. So now that's a square root we need to raise to a power that would cancel out a square root.
Power of 2.
Power of 2. Yep. So we're going to raise each side to the second power. What happens when you square and square root?
It cancels out the square root.
Cancels out. And what are you left with on the left side?
It would be 17 to the power of 2, so...
Left side, we'll do that one first.
Oh, no. It was going to be 2x plus 3.
2x plus 3. And now we need 17 to the second power.
That is 289.
289. All right. Right. What would our next step be?
Subtract 3 from both sides.
Subtract 3. Looks good. So 2x equals
2x equals 286.
286. And our last step.
We divide.
Yep. Divide each side by
2.
2. And what is 286 divided by 2?
143.
143. And because we're solving a radical, what should we always make sure we do with our answer?
Substitute it.
Yeah, let's check it. Okay. What's, if we plug that in, what's 143 times 2?
That is the 286.
286. What's 286 plus 3?
That is 289.
289. And what's the square root of 289?
Square root of 289 is 17.
17, and then take away 5.
That is 15. Wait. 12.
12. Yep. And that's exactly what we were supposed to get. Right. So that's solving a radical equation. So for the next question, we're going to look at these 4 different things, and they're all related to the equation y equals square root 2x plus 1 minus 4. Okay, so first thing I want to know is, does this kind of graph have a start point or a center point?
Give me a second. Because my notes. Okay. It has.
So it's all based on the index.
The index. So.
Yeah. What's the index in that one?
2.
2. And that's an even index. So even index roots always have a.
Always include.
So it's either start or center.
Or start or center. Okay. And then so this would be a start.
This one has a start point. Yep. Because it's an even root. What kind of root would have a center point?
An odd one.
The odd ones. Yep. Okay. Are there any reflections in that graph?
No.
No. When you do not have any reflections, what is the direction that a square root always goes in?
To the right.
To the right. Yep. So that one will go towards the right. Now the y-intercept. The y-intercept is where it crosses which axis?
The y-intercept is when it crosses which axis? The y-axis?
Yes, it's where it crosses the y-axis. So this graph, I don't know exactly what it's going to look like, but it might look something like that. Maybe a little bit lower. We don't know what this coordinate is, but we want to find it.
Okay.
But we know something about that coordinate. What do we definitely know about that coordinate?
That it has a x of 0?
Yes. That's how you find the y-intercept. You let x be 0, you plug it into your formula, and then you find y. Okay, so let's try that. If we plug in 0 for x, what's 2 times 0?
0.
0 plus 1?
1.
1. What's the square root of 1?
1.
1. And what's 1 minus 4?
-3.
-3. So -3 is where this graph is going to cross the y-axis. So as I said, the graph should be a little bit lower than the way I drew it because it's been shifted down 4 units. But that's okay. All right, and now the domain. So when we're dealing with square roots, we have to make sure that the radicand is always what number or higher?
0 or higher.
Yes. So what we want to do to figure out the domain is take the radicand and make sure that it is always 0 or higher. And now we're going to solve that for x. And that'll give us our domain. Okay. How do you solve that for x?
For x, set the radicand to equal 0.
Well, we're setting it greater than or equal to
To
0.
0.
Yeah, because we're trying to find all the numbers that we can plug in that will make sure this is never negative. So how would we solve that now?
Subtraction from both sides.
Okay, and what would that give me?
That would be 2x is greater than or equal to 1.
Careful.
Oh, negative.
-1. And what would be our last step?
Last step, to divide.
Yep, and what would you divide by?
2 on both sides.
2 on both sides. So we get x is greater than or equal to.
Negative 1 divided by 2.
All right. That's how you could write your answer as an inequality. But what if I asked you to write it as an interval? How would you write your answer?
Decimal form?
No, you can leave a fraction in the interval. I just don't want a greater than or a less than symbol.
Oh.
So now I'm looking more for an interval. So the interval is when we usually use like brackets and parentheses.
Oh, okay. So it would be. Okay. 0. No. Brackets. Negative a half.
Mm-hmm.
And then it would be a bracket on it.
Yep, because you can include it.
Mm-hmm.
Okay.
And then after that, it would go to infinity.
Okay, and go to infinity.
Except that one would have a parentheses.
Parenthesis.
And then I'm kind of lost from here.
Well, we need one more thing to make that an interval. We left something out that we always put between those two things.
The comma?
Comma. Yep, exactly. So that's how you'd write your answer as an interval, from negative 1/2 to positive infinity. Yep, perfect. And that answers every question that they wanted to know about that graph. All right, so next one we're going to look at is solving a rational equation. And the goal here is to first multiply all 3 of these fractions by the least common denominator. Okay. What we always want to check first is see if this denominator on the right is the product of the 2 on the left.
Okay.
If it is, then the 2 on the left are what we need to use. So let's FOIL the bottom and just check. What's x times x?
X squared?
So we're just going to do x squared, and then x times negative 1,
Negative x.
and then plus 2x.
Plus 2x is. Wait, repeat that again?
So negative x, then plus 2x.
And plus 2x is 1x. Which is
1x. And 2 times negative 1.
Negative 2.
So is the product of our first 2 denominators equal to the third one?
Yes.
Yes. So that's good. So now, what can we multiply each fraction by to cancel out all my denominators?
Each fraction by x plus 2
X plus 2
and x minus 1.
and x minus 1. Yep, that's going to go in all 3. All right, now let's cancel out what we can. What's going to cancel in the first fraction?
In the first fraction, when we multiply them,
Yes,
the x plus 2,
x plus 2. And the second fraction?
x minus 1
X minus 1. And the third fraction?
is going to be both the fraction of the denominator.
Yeah, because that is that when you multiply it out.
Okay.
Okay, so now let's see what we have left. The 3x is a distributive property.
Okay.
And what do you get when you distribute that to the parentheses?
That is going to be 3x squared minus 3x.
Yep. And now the next one, you are distributing a positive 2.
It's going to be to the x plus 2.
Mhm.
2x plus 4.
2x plus 4. And what's left on the right side?
The 5.
The 5. Okay, so now what kind of equation is that based on the highest exponent?
Quadratic?
Yeah, that's a quadratic. So to solve a quadratic, we want to get it equal to...
0.
Yep, I'm going going to get it equal to 0. So let's combine what we can for like terms, and let's put everything on the left.
Okay.
So we have 3x squared. What's negative 3x plus 2x?
Negative x.
Negative x. And if you bring the 5 over to the other side,
It's going to be negative 1.
negative 1. And what's on the right?
0.
0. Okay, now before we start solving this, there's two numbers we want to keep in mind, because if we get either one of these numbers, we'd have to cross it out and say it's extraneous.
Right.
What number would you not be allowed to plug into that first denominator?
Anything that is
Just a single number.
2?
If you plug in 2,
Sorry,
you're okay.
negative 2.
Yeah, negative
Negative
2.
2, right.
Yeah, you can't plug in negative 2. And what number are you not allowed to plug in the second denominator?
1.
1. And then what two numbers are you not allowed to plug in here?
That would be 1 and 2.
1 and...
Oh, 1 and negative 2.
1 and negative 2, because it's the same denominator as we already had.
Got it.
So if we get a 1 or a negative 2 when we solve this, we need to cross that answer out.
Okay.
So we'll just 1 and negative 2. So just keep those two numbers in mind. So first thing, we could try to factor it, but that doesn't look factorable to me. So if you can't factor, what else can you do?
Quadratic form.
Yep. What's A going to be?
A is going to be 3.
And B?
Going to be negative 1.
And C?
Negative 1.
So now, can you start to fill in the quadratic formula using those values?
Yep. So it's going to be negative 3.
So first thing in the quadratic formula is negative b.
B. So it's going to be negative 1.
Negative 1. Yep.
And then it's going to be plus or minus
Okay.
the square root
Yep, that's good so far.
negative 4.
So next thing here is b squared.
B's, oh, that's my fault. So it's going to be 1.
1.
And then minus 4
Yep.
times A,
All right.
which is going to be the 3. And then times C, which is going to be negative 1.
Negative 1.
And then it's all going to be divided by 2 times A.
And 2 times a
Is 6.
is 6. All right. Now, what's going to happen under the root when you subtract a negative number?
When you subtract the negative number,
Yeah.
like the 4 from 1.
So you're going to be subtracting a negative under that square root. So what does that really mean you're doing?
It's imaginary.
No.
Wait,
You're subtracting a negative. You're minusing a minus.
you're minusing a minus. That's just positive.
Right, it's going to be addition. So that part, we might as well just cancel that and make it addition right now.
Oh, okay. No, I see what you mean. Okay, thank you.
Yep.
So that's plus. Got it.
And what are you going to end up with for your radicand in that spot?
16?
Double check it.
14?
Okay, walk me through how you're doing it.
Alright, so I do 4 times 3
Which
That's
is 12.
plus the 1. No, sorry, times the 1.
Times
12.
1, which is 12.
And then plus 1 equals 13.
13.
Okay, I think I
Yeah.
added it.
Okay, so we get 1 plus or minus root 13 over 6. And the two numbers that we needed to look out for were negative 2 and 1. And that's not either one of those numbers.
Okay.
So that is the answer to that problem.
Okay.
And you would have to do something like that algebraically, because if you try to use the graphing calculator to graph it and do something with that, it is not going to give you an exact answer like that one.
Okay.
Okay. So this one is another solve, but we don't have a third denominator we need to worry about over here. So we just have to focus on the first two. So what would you multiply each fraction by so we could cancel out all our denominators?
The denominator on both.
Which would be?
The x and the x plus 5.
Yep. So x plus 5, x plus 5, x plus 5. Well, let's start with the right side. What's the right side going to come out to when you multiply all three of those together?
0.
0, yeah. So we don't have anything to worry about on the right. Now, what's going to cancel in the first fraction?
The x.
Yeah, the x is going to cancel. And what's going to cancel in the second fraction?
X plus 5.
X plus 5. All right, so now let's see what we have left. Let's start by distributing that 2. And tell me what you get when you're going to do that.
Okay, when you distribute the 2, it's going to be 2x plus 10.
2x plus 10. Okay. Now, be careful with the next part. What are you distributing in the next part?
The 3.
And?
The x.
No, you don't have to distribute the x, but there's something else you're distributing besides the 3.
Negative.
The negative. This all goes together.
Okay.
So what do you get when you multiply that times x?
Negative 3x.
Negative 3x, and that equals 0.
Okay.
All right, what would be our next step?
The next step would be to put all the x's together in this.
Yep. And if you combine all of them together, what do you get?
Negative x.
Okay.
Equals.
And what would be, we could finish this in one step if we do the right thing.
Subtract on both 10 from both sides.
Well, you could, but then you're going to have to do something else after that.
Okay.
So there's something else you could do and you'll be done in one step.
Would it be divide?
Nope, nothing you need to divide. Remember, the goal is to do what?
Factor.
Well, factoring is a technique to get to the goal. But what would the goal be in this problem?
To make it equal 0.
No, we don't want to have 0 by itself when we're all done, because it's not a quadratic.
This is 4.3, right?
Yeah, but it's not gonna be in there. It's more something like from Algebra 1. Think of like what is the goal in that problem?
In this whole problem right here?
Yeah, right there.
Get rid of the negative?
The goal is to get x alone.
Excellent, okay.
Yeah, you want to get the variable by itself. So what's some way you could get the variable by itself in one step?
By
Add x to both sides.
adding x to both sides.
Because if you add x to both sides, what happens on the
Cancel
left?
itself out.
That's gone. So what's on the left now?
It's going to be x.
No, on the left.
10.
10.
10 equals x.
You're done.
Okay, thank you.
Yeah. So if you add the x to the other side, now you have x equals 10, and you're done.
All right, thank you.
Yeah, you're welcome. All right, so now we've gone to a problem where we had 3 denominators that are not 1. Then we had 2 denominators, and now we're down to one with just 1 denominator. So in this case, what would you multiply each side by?
X plus 1.
X plus 1 and x plus 1. And what's going to happen on the left side?
Going to cancel out the x plus 1.
Let's cancel. And what do you get on the left?
5x plus 5.
So on the right, we get 5x plus 5.
Yeah, and then we get 3 on the left.
And we get 3 on the left. Yep. Now, what would be your next step?
Let me see, let me write this down. Move the subtract 5 from both sides.
Subtract 5 from both sides. So that's gone. And what's 3 minus 5?
Negative 2.
Negative 2. your last step?
Divide.
Yeah, what would you divide by?
5 on both sides.
5 on both sides, perfect. So for x, you get -2/5. Now, we forgot to do this on the last one, but it worked out okay. You should always plug your answer back in and check it.
Mm-hmm.
What number would we not want to get for x here? Because that would be a problem.
-1.
Yeah, we don't want to get -1, but we didn't get -1. So that answer is okay.
Okay.
Yeah.
Thank you.
Yep, and the same thing on the last problem. We didn't want to get 0 or -5 as an answer.
We didn't
and
get
we didn't. We got 10. So we didn't check it, but it worked out okay. So last question we're going to look at is solving an equation that's a rational equation, but we're going to do it graphically. Okay? This one would be a little bit more complicated to do algebraically because it has a cube in it. So if we had to start dealing with things that are cubed, answers don't always come out as nice. So first thing we need to do is plug that into the calculator, which we've already done. X cubed minus 3x plus 5 is my numerator. X plus 1 for the denominator. And what do we have to put on y2?
20.
20, yep. And we can see that it does cross it
3 times.
3 times. So what we'd have to do, we got to find all 3 of them. And we're solving for x. I already know the y value of all 3 of these points. What's the y value?
5? No, 1.
No, not 1 or 5. All those points are on the red line, right? So what's the y value then of a coordinate on the red line? Just the y value of any point on that red line.
20?
Yeah, we already know the y value of all those points is 20. What we're interested in is the x. Okay, so how do you find the x value?
Finding the intercept.
Yep, and what do you press to do that?
Second calc 5.
5. Now, does it matter where we put our cursor?
No, it just has to be on the 2 lines that we need. So it needs to be close to where you want the
Right.
intersection to be.
So we can pick a point anywhere on the blue one, and then we can pick a point anywhere on the red one, but then we have to put our cursor close to the one that we want first. Okay, so I'll do the one on the left first, and we get that as our first intersect, -4.43. And now we've got to do the same thing 2 more times, but move your cursor now closer to that other intersection point.
-0.66.
Yep. So you know what I'm going to do? I'll put that there, and then I'll put this one like that. So there's your second one. And now the third one, what did you get for that one?
For that one, I would get, that is 5.1.
Yep. So we'll go, I'll just do 5.09. I'll just leave that. But those are all your intersection points.
Okay.
Okay. Any question on finding all of those?
No, I got that.
Okay. So in this particular problem, we did have to set our window to zoom out, because if you use a standard window, you'd never see 20. So keep that in mind, that you may have to zoom out. Okay, the next thing they want to know is the root. Okay, so let me grab that picture again. So we're done with the red line. We really don't need that anymore.
Okay.
When they ask for the root, they're asking basically graphically where what happens.
Where does the red line hit those ones?
No, we're done with the red line, so we don't need that anymore. That was just where it was equal to 20. Now they want the roots of the blue equation.
Where it's 0?
So where where it's 0, but that would mean where it crosses what?
The y-axis?
X-axis.
X-axis.
So how do we find where it crosses the x-axis?
Find whatever line is touching. So it would be 0, it would be second calc,
Yeah.
and then 0.
Second calc, and then 0. Yep. And we're going to pick a point. I'm not sure if it's crossing more than once. We're going to have to check that out.
Okay.
But we definitely know we got a crossing right there. So one of our zeros is at negative 2.28. Did you get that answer as well?
Give me a second, I think I did it wrong. Let me go back. I didn't put it between the right points. That is 0. Then I go between here and here, and I get negative 2.279. So yeah,
Yes.
2.28.
Now, I zoomed in a little bit so that I could see this area better. When I zoom in and look at the graph, is that area that I circled, is it crossing the axis in that spot?
It's getting really, really close, so I'm not too sure, but no.
No. So if you look at the zoomed in version, it's not.
Oh, okay.
Yeah. So we
It's
can.
really close there.
Yeah. So it gets down to about like 1.5 or a little above 1, but it
Right.
never gets.
But it never touches.
Never touches. No. Okay. So find the roots. So that. The 0, the root, that's the same thing. So we got that. Are there any extrema in this graph? Local extrema, either local minimums or local maximums?
It's wherever. No, I don't think I mean where you circled in the middle right there.
Yeah, what is that? That's a local, which one?
Local minimum.
That's a local minimum. It's a point that's lower than everything else around it. It's not the lowest point ever because this part just keeps going down to negative infinity.
Yeah.
But in that area, it is the lowest value. So how do we find the coordinates of that point?
Minimum. The second calc minimum.
Yep, second calc minimum. And we just pick a point to the left, to the right, hit enter, and we get the coordinates of our minimum. So just to make sure we know what each number means, the x is basically where the minimum is, and the y is like what the minimum is. So what that means is if you wanted to figure out what number you would have to plug in, like where on the x-axis to get a low value, if you plug in 1.21, if you take that number and you fill it in for each of those x's, you will get 1.42.
So that's all I can check.
Yeah, if you plugged it back in, you would get 1 point. You could, yeah.
Okay.
So the 1.21 is where the minimum occurs, and 1.42 is actually what the minimum is. That's as low as it goes. I thought it was like 1.5, but it's 1.42.
Okay.
This particular problem only has one local extrema, so just one. You always need to make sure you zoom out enough. What enough means is different in every problem, but you got to zoom out enough to make sure there are no other local extrema off the screen.
Okay.
This one is in the standard window, but they might not always be.
Okay.